I'm going to hit record. I'm going to record this session, and I've been asked via email to compute, do the following problem. Now, what makes this problem difficult or challenging? Well, I am glad you asked. Okay, the reason that this is a little bit challenging is because you're sketching a region in 2 dimensions in the XY plane. Okay, and there's a really basic strategy for this kind of problem. So I'm going to just work through that with you, and we can do that together. So let me share my document camera with you. Okay, so let's see if we can do this together. So the set, so this is question 3, sketch. So I'm going to call this set omega. So it's all those points such that in the first case, x is between 0 and 2, and y is between 2x and 0. Okay, so this is part A. All right, so the strategy that that I'm going to use for this is to sketch the lines on the boundary or the edge of the set. So one strategy sketch the lines on the boundary or the edge of the set. Okay. So we've got x equals 0, x equals 2, y equals 0, and y equals 2x. Okay. So there are my axes. And so I'm going to put in the line x equals 0 and x equals 2. So x equals 0 is just this horizontal line. X equals 2 is this horizontal line. Vertical line, not horizontal. And the line y equals 0, well, that's just the x-axis. And then you've got the line y equals 2x, which is going to look something like that. Okay, so what I've done is I've just sketched the boundary curves, okay, or the boundary lines. And what we want is we want x between 0 and 2. So we're in this strip here, and we want y above 0 but less than this line. So the region is this triangle here. Okay. So this is bounded there, 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 and there. Okay, that's sort of the edge, if you like. Okay. Now, if you do some more mathematics in second year, for example, if you're studying, I don't know, engineering, something like that, you'll look at doing integration and calculus over these 2-dimensional regions. We don't do it in this course, but you might do it next year. So it's really good if you can understand the geometry and what these sets look like. Okay, so what about the second part of this question? And then feel free to just ask questions if you want in the chat, because I'm curious to know what you're thinking, right? So this is the next part of this problem. X between these 2 lines and y is between these 2 lines. Okay, So let's go back and we can see what that looks like in the same sort of setup. So let's call the set, I don't know, theta. Okay, and it's going to be the set of points such that x is between y on 2 and 2 and y is between 0 and 4. Okay, so we're going to end up with a sketch like this, and we're going to do the same strategy. All right, so let me draw in the axes. Okay, and I've got y is between 0, which is the x-axis, and the line 4. So let's put that in. Y equals 4. Okay, so there's my little strip there, and I know my points are going to be somewhere in between, somewhere in between these two lines. Okay, now x is between 2 and y on 2. Okay, so if I go down here, this is the vertical line, x equals 2. I know that I have to, like, I can't go to the right of that because x is always to the left of that line. Now the line x equals y on 2, that's actually going to be this line here. Okay, it's the same line as y equals 2x. So where is my region? Well, I want to be in this strip, to the left of this curve and to the right of this curve. So there you go. Okay. Now, who can tell me in the chat, are these actually the same? Are they the same regions? Is it the same? Are they actually the same set of points? Yes or no? Who can tell me? Is this the same as this? Are they the same region? Do they occupy the same points? They do, Tiffany Aichen. Thank you. So we can note that even though the descriptions look different, the descriptions are different, the sets of points are the same. Okay. So they both occupy the same space. So what I guess one of the interesting things here is that you can describe these sets slightly differently, but they're the same set. They're the same set. Okay. Okay, so there's a question from Doha. Hello, Doha, how are you? End of chapter 1 calculus notes. Can you briefly explain what kind of questions come up for discontinuous graphs? Okay, so for discontinuous graphs, on page 22, let me have a look, 22. Yeah, okay, good question. Okay, so let me just share that with you, Doha. That's a good question. I can share my my thing here. So thanks for your question, Doha. It's a good question. So these three functions all behave a bit differently. Okay, and what the text and the ideas here are trying to say is that this kind of jump is different from this kind of jump. Okay, and they're different from this kind of jump. Okay, what the first one can do, it's basically you can fill this little hole by redefining that black point to be up here. With this, you can't do it. And with this, you can't do it as well. Okay, so they all have jumps in their graphs. You can fill this hole easily, but you can't fill that one because the jumps to like you just can't do it. You can't connect it, and the same with this one. Okay, so this is what they mean when they say plug the hole at A. You can do it there, bloop, but you can't do it there, and you can't do it there. Okay, so what kind of questions would you have? The question might be something like, this function has a discontinuity. Can you remove the discontinuity? Okay, but I mean that's more of a question for chapter 2, because we'll be talking about continuity and stuff like this in chapter 2. Okay, Doha. So does that help a little bit? I'll give you. Let me give you an example. I'll just write something down very simply here on my document camera. Let me see if I can. Okay, so if I have a function like this, okay, that's my function, and I'm defining it to be my function. Technically speaking, I cannot include 0, okay? Because, you could think, well, I can just cross them off and get 1. You can't, because if x equals 0, you can't do that, okay? So what we could do is say f of 0 is not defined, but we can define it to be, say, f of 0 equals 1. Okay, you could do that. It's up to you. Okay, so that's an example of a removable discontinuity. Okay, the other graphs are a little bit more difficult. Okay, let me show you something else that I think is pretty cool. How confident? We're going to put this in the chat. How confident are people with Maple? Does anybody know what Maple is? I can show you a little bit. Are people really confident? Have people seen it before? Let me know is it all new to you? Yeah. Tiffany, good question. Anna, yes. Aichen. Aichen's used it for Math 1031. Doha's somewhat familiar. Kevin, not so much. Okay, let me show you some cool things in Maple, because you will need Maple for the final exam, right? So this is like a Maple window. And what I can do, I can start a new document. Yeah. And then there's lots of things that I can do with commands and things like this. But let me just show you some really basic ones. Okay. There's one question from this week's tutorial, and it's something like this. I'm just putting this in the chat. Okay. You're asked to solve sine x equals cosine x. Okay. So what you can do is you can do this a few ways. I can make that a bit bigger. Let me see if I can. Oops, sorry. Oh, sorry, I keep pressing the wrong stuff. Okay, so I'm going to load up the plot calling sequence, and I'm going to plot sine of x minus cosine of x. Okay. Okay. So you can see in this graph, I haven't done anything spectacular. I've just asked Maple to plot the function sine of x minus cos of x. And I can see that the solutions are where the graph cuts the x-axis. Now, if I wanted to sort of make that a bit bigger, I could specify my input. So x is between negative 100 and 100. You can see it really changes it then. You go like this. Okay. So judging from that graph, how many solutions will this equation have? You can tell me in the chat. How many solutions are there? Yeah, H and Tiffany, Nathan, exactly. So there are an infinite number of solutions. Now, let me show you how Maple sort of fails at this, right? So there is a command called the solve command, or the fsolve command, which gives you the solving capabilities. Okay, so here what I'm doing is I'm saying, okay, let's solve this equation with respect to x and see what happens, okay? Now, that's a bit of a fail because Maple gives us one solution. That solution right there. It doesn't count that one or 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 any of the other ones because there's an infinite number. Okay, so just be careful when you're working with Maple. It's always good to draw a graph or plot a graph because you may actually not get everything you want from Maple. Okay, so the solutions for this one then, how would you capture them? Well, if I was writing this out, what I would do is I would, okay, if I'm solving this, okay, I would put, okay, well, from our graph, you have something like it's x equals pi on 4, and then you're going to add pi and take pi away, right? So it'll be pi plus pi, oops, sorry. Okay, etc. And pi on 4 minus pi. Okay, so there's an infinity of number of solutions here. Now, there's of course other ways to do this problem. Okay, and yeah, it's like a general solution, Nathan, right? So you could, if you wanted to write down the general solution, what you could say is you could say, all right, x equals pi on 4 plus or minus k pi. For k equals 0, 1, 2, da, 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 da. Okay, that would be one way of capturing it. Okay, so not a difficult problem. Some people also like to solve this in a slightly different way. They divide both sides by cosine, and we are considering something like this. Okay, so let me show you how to solve this equation in Maple, and it'll be interesting because you'll see how to plot two curves on the same set of axes. So let me go back to, excuse me, Maple, and I can show you. All right, so let's say I wanted to plot the tan curve and the horizontal line x equals 1, or y equals 1, right? So I can plot tan of x, and I can plot 1. Now notice I'm putting in the square brackets here, so it's sort of a bit like plotting a list of functions here. And let's see what happens. Okay, so you can see the red curves are the tan curves. The blue horizontal line, that's the line y equals 1. And they cut here, 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 here. In fact, they're exactly the same places where this curve cuts the x-axis. Okay, so that's another way of doing it. So with this one, what you can do is you can let me just make that a bit bigger. Oops, sorry. You can put in square brackets here, and you'll get two curves on the one set of axes, which is kind of nice, right? It's kind of nice. So let me just make that a bit bigger because you might be struggling to see it at home. Okay, so there's a couple of simple things you can do with Maple that you'll be using Maple in your lab tests and in your exam. So the first thing is the plot command. The second one is the solve command. So be careful of the solve command. And the second one is where you've got two graphs that you want on the one set of axes. Okay. So Doha, I'm not sure what you mean by smart plot. Can you give me an example? All right, let's do another one from the PDF. And Doha, you can talk about the smart plot if you want. I wanted to do a slightly more difficult question. I think I'll do part 8. Okay, so I wanted to look at this one first. Okay, so the H means it's hard. So I think it's okay for this kind of tutorial. But let's look at it first. You want to prove the following, and then you want to use that to prove another inequality. Okay, so the first thing, let's look at this first, and I'll actually do something in Maple, and I think you'll like it. And then we can worry about the second part in a minute. Okay, so let me go back to Maple, and I'll show you. Oh, sorry, wrong one. Let me choose the right window. Okay, so what you can do is, I'll go up here. Okay, so let me show you another really cool thing that you can do with plots. Can go up a bit there. Okay, I'm going to show you the plot 3D command. Okay, so we've got this thing, what is it? X plus y all squared. And I'm going to plot it in 3D. Okay, so I've got x plus y all squared minus 4 times x times y I'm going to plot this function in three-dimensional space. Okay. So there you go. So the X and Y axes are down the bottom, and the Z axis, the vertical axis, is this one here. And you can kind of see from the picture, the points on the surface always lie above the XY plane. Okay, so what that kind of means is we know that this is definitely going to be greater than or equal to 0. Okay, so plot 3D is really amazing because you can visualize stuff in 3 dimensions, which is really great, and you can move it around and stuff. Okay. All right, so how do we actually prove it? Well, let's go to my my document camera, and we can do that together. Okay, so this is question 8, I think now. We're asked to show that the following is true. It's for all X and Y. Okay, so X is a real number, Y is a real number. Together they form this plane, right? The R squared. Yeah, Nathan, that's a great suggestion. Write it at the bottom of the page and work backwards until you have something that is definitely true. Absolutely. Okay, I'll give you the thumbs up for that one. That's a really good suggestion. Sometimes working backwards is a great strategy. So the way I'm going to do it is I'm just going to move this around and then show that it's greater than or equal to 0. Okay. So I'm going to let f of x be this minus that. Okay, and we're going to show that f is greater than or equal to 0. Okay, and that's going to be true for all x and y. Okay, so consider, please. Let's consider this. We'll expand the squares and see what happens, right? So let's expand this out. You can see I can simplify these terms. And now I can put it back together again, right? This is a perfect square here. Oops, sorry, minus. And we know that this is definitely non-negative. It's got to be greater than or equal to 0. Okay, so when we square something, we can't return a negative value. So we have an inequality here. So this is obviously greater than or equal to 0. So we could make a little nice assumption, or a conclusion there that star holds. Okay, we're pretty happy. Okay. All right, so keep the suggestions coming. The second part of this is a little bit more complicated. Let me go back to my PDF. Okay, so the second part is hence deduce that this holds. Now, who can tell me, what does the word hence mean to you? When you see the word hence, what do you mean by, or what do you understand by the word hence? Okay, Nathan, use the previous part. Brendan, using previous part. Tiffany, use what you proved. Doha, use the previous bit. Chen, use the previous answer to prove. Yes. So hence is a bit with what you just did. Something like that. Okay. So they're giving us a clue. Use this information to solve this or prove this. Okay. So let's work with it and see what we can do. So back to the document camera. Okay. So let's consider. This is part B now. Oops. So let's consider the following. And just like part A, I want to show that this whole thing is greater than or equal to 0. And of course, we are excluding 0, right? Because you're dividing by 0. Okay, so yes, you could do a substitution, Nathan. I haven't quite done it that way. Substitutions are great. You could say, okay, let A equal 1 on X, B equals 1 on Y, or something like that, and use part A. That's very clever, actually. I'm going to do it a slightly different way, maybe a bit more pedestrian. Okay, but you'll see mine's probably a bit longer than that. I think I like yours better, actually. So what I'm going to do is I'm going to put this all over one common denominator. Okay, so let's put this over one common denominator first, and then I'll do the other term. And then you can put this over one common denominator just by cross multiplying. Notice you've got the same thing there. Okay. Now, what you notice about this, that's got to be positive, that the denominator's got to be non-negative from part A. So, sorry, the numerator. And the denominator is always positive. Hence, let's call this double star. Double star is always greater than or equal to 0. Okay, but I like your idea there, Nathan. I think a substitution is probably better. Yeah, so I think that's very clever. This is probably a couple of steps too much. All right. All right. So that's that one. Let's keep looking. I need to. Yep. So Doha, I'm just looking at the Maple notes. I don't see anything about smart plots there. So Yeah, so the numerator is greater than or equal to 0 from A, because imagine this is like your X and that's your Y. Okay, Maximilian? Okay, and this is like, you know, you can think that is your X and that's your Y. So it comes back to Nathan's suggestion about making a substitution in the end anyway, even though I didn't do that at the start. Does that make sense, Maximilian? Yeah, sorry, it's a little bit jumbled. I'm not completely happy with that solution, but yeah, it would have been better if we let X equal A and Y equal B, and so you've got different letters. That would actually be a lot better. Okay, Kevin, how do you know the good question? How do you know the denominator is greater than 0? Bump, 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 because X and Y can't be 0. And if you square non-zero numbers, you always get a positive value. Does that make sense, Kevin? Yeah. So obviously, if we divide by 0, it's death. So we definitely want to exclude the bad case. All right, let's keep on going. Okay. Okay. All right. Let's go and have a look at another question. Now, this is not a particularly difficult question, but I think it's interesting to maybe have a look at it in Maple. So let me just show you. As you can see, part of what I'm trying to do here is to get you a bit more comfortable with Maple. There you are. Okay, so there's a question. Actually, I'll go to my PDF first. Let me show you the PDF first. Here we go. All right. So there's a question here which involves quadratic equations or curves, right? And it says sketch the graph of this, and hence, again, there's that word again. Sketch the graph of this. Okay. So I wanted just to do that in Maple to show you how you can do things involving absolute values. All right. So let me go back to my Maple. And I'll just bring that over there. Okay. So here I'm going to plot. Oops. So I wanted to plot two things here. Okay. So I'm going to use the square brackets. I'm going to do the absolute value of that. Okay, so for absolute value, you can just use ABS, or you can use these common symbols over here on the right-hand side. So you don't actually need to know the command, which is nice. Okay. So there it is. All that's really happening there is you can sketch the regular parabola here, and then the idea is to fold the negative part back along the x-axis, so you have this reflection. Okay, so you know, I guess the red curve is the original parabola, and then the blue curve is, you know, the reflected part where you reflect the negative part through. So because when you take the absolute value of something, it can't be negative, right? So that's a really easy example of how to use the plot command with absolute values. Okay, and then there's another question here, which I'll show. just with the PDF, so just bear with me for a second. Okay, it says use a graphical approach to solve this. Okay, so let's say we wanted to solve that. Okay, so let's plot it first in Maple, and then we can solve it. Does that sound okay? So let me just bring it up here. So while you're writing that down, I'm just going to put it into Maple. And just give me a second. And what is it? It's x plus 2. Okay, so you can, I'll just get rid of that. So here it is. You can see I've plotted, the red curve is the one with the absolute value in it, and the blue curve is just the curve x plus 2. You can see here they're going to cross. So all you need to do is work out that point. It looks like it's going to be, you know, around about here. Okay. And so let's say I actually wanted to solve it. I could just go, all right, solve this minus that equals 0 with respect to x. Okay. So there's one solution, there's another solution. There it is. Doha, sometimes you can ask Maple to look for solutions in specific spots. So you can ask Maple, so for example, you might want to plot a curve, but you're only interested in it for a certain interval. So yes, you can actually, you can do that. You can do that. Okay. All right. All right. Well, that's we're just about out of time, everybody. So I think if anybody has any final questions or any kind of you know, questions about the course or anything like that, definitely put them in the chat. Yeah, Joseph, I think you're right. I still think it's manually easier to understand than typing in the plot code. It is, right? I think I'm just trying to start with basic examples, but when you get to really complicated examples, Maple's much easier, trust me. It can just do so much stuff that you can't do by hand. Doha, it's a good question. The lab tests are harder than the weekly Mobius tasks. The best advice that I can give you for the lab tests is that you'll get practice lab tests. Okay, so before the real lab test, you'll get at least one practice lab test. Okay, and what you should do is just familiarize yourself with the questions and do the standard will be the same. The level of difficulty will be the same. Okay. iChan, hang on, let me see if I've got it for you. I don't have time to do it in 1 minute, but I might have it somewhere. Let me, yeah, this is what I've got. Let me show you quickly. So this isn't a full solution, but this is kind of what I was thinking of when I was doing that problem. Hang on, is that, did I prove it? Oh, this is part B, okay? So it's a bit of a mess, It's a pretty, I mean, I think all they really want you to do for part B is just know that if you take the composition of two polynomials, for part A, the composition of two polynomials gives you a polynomial, and the same is true for rational functions. So if you compose a rational function with another rational function, you get a rational function. That's the most important thing. Okay. All right. Last question. Is there a time limit on the lab test? Yes, Tiffany. Yes, there will be a time limit, and you need to submit it before the due day. And students always say, "Oh, I was in a different time zone. I didn't know." Yeah, it never works. So the best thing is to just be really conscious of all the time limits and the time and the submission time. Okay. Yeah, and if you start the test and you close the window and you go away, the time keeps going. Okay, the time doesn't stop. All right. Joseph, no, I don't think you have unlimited tries for the lab test. Okay, and you can't click the "How did I do" button. That's not in the lab tests. Okay, everybody. Thanks for joining me. See you in the lectures or in the tutorials. I got another tutorial at 4 p.m. So if you want to come in an hour or so, feel free to join us. Good to see you. Enjoy the day, and I'll see you in the next class. Okay. Bye, everyone.